Good evening. This is the Mars rover final report, and I am Jaira James, and mechanical engineering major.
My name's Cooper Jevic, and I'm also a mechanical engineer major.
My name is Natalia Nikolic. I'm a civil engineering major, and I'm a sophomore.
My name is Joshua Pruitt. I am a mechanical engineer. I am a freshman.
So
our project was to create a rover for Mars and scientific data study on the surface of Mars. Yeah.
you cut out.
Hello.
Yeah, so this was a potential contract to design a Mars rover that can collect scientific data on the surface of Mars. The rover that we build would have to complete certain requirements for NASA to consider it. We would have to have it be able to navigate terrain, to avoid obstacles, and follow commands. And the way that we did this, or I guess the test that we used for it, was line tracking, obstacle avoidance, and Bluetooth.
Okay, this is our backgrounds in robotics. I'm Jaira James, mechanical engineering major. I do not have much experience in robotics, but putting things together and taking them apart is one of my hobbies. And I have experience in information technology and programming, so I was able to participate in both hardware and software within the Rover project.
I'm Natalia Nikolic, and I also don't have very much experience in robotics as I'm a civil engineering major, but this was a great experience for me to enhance my knowledge on software and learning a little bit more about robotics and how hardware functions.
My name's Cooper. I'm a mechanical engineer, of course, and I was a software engineer for this project, and it really helped me learn a lot about the software and electrical side of even mechanical projects.
I don't know if we lost Josh there, but he was a member of a robotics club in high school. So I think that he had the most experience out of all of us and was very helpful in the process.
Okay, manufacturing activity, hardware. To make the rover, I and Josh started to open the rover kit, and we organized the bags in a way like so we can see which one goes where. Then we follow the instructions in order to put certain parts of the rover together. Yeah. Josh, can you speak? Or
After that, we made sure that the rover supplies were in order by checking the direction. And after we solidified that all the components were there, we put it together starting from the bottom and screwing in the components. Then we did the same with the top and connected them together and added the tires.
There is a
Cooper
manufacturing
and I
software.
worked together.
Go ahead.
Sorry.
Yeah.
I was gonna say Cooper. No, you're good. Cooper and I worked together on the software process behind the robot. So some of the things that we did was initially we had to go through a little instruction by Dr. Burrs explaining to us how to download the software, upload it onto our computer. And after that, we had to connect the Rover to Bluetooth through a USB to our computers. And then from the computer, as we downloaded the files, we had to program them onto the robot to make sure that it would be able to complete all actions that we said, like navigating terrain and line tracking. Those things, we were able to test the robot and see if there were any improvements or tweakings that needed to be made to ensure that it would work.
Yeah, and it was a little rough at first, and we tried to download from the computer to the robot, but eventually we got the robot when downloading each individual part, like she said, the navigation and obstacle avoidance, all of that. But after we were able to download it onto the Rover,
I think we also had some difficulty in extracting the files because when we first started it from the our laptops, we didn't realize that we had to extract the file but onto the robot. So I think that was where a lot of the confusion was. But through trial and error, we figured it out and were able to upload it.
Yeah.
Here we have the test results for our DD250. The Rover was fully capable of line tracking, obstacle avoidance, and Bluetooth control. And to the right, as you can see, there's a DD250 form. This is a confirmation that the Rover is able to perform everything that is required of it, as well as proving it is built correctly with all the necessary parts.
Yeah, and on form at the very
Here is the line test that was performed by the robot. As you can see, the robot was able to correctly follow the path of the line and did not come off the chart. So it was programmed well.
And just to add, this was the most difficult line to follow.
Yeah. In conclusion, all members work well with each other and agreed upon roles quickly. The rover was built exactly as instructed, and after completing the software, it was synced within the Bluetooth attached to the rover, which helped the rover successfully complete the different tests. The construction of the rover was a bit difficult because of the small pieces that had to be attached, but the software was easier because we did not have to write the code from scratch. At the end, the project was a success and all members contributed equally, and we were all satisfied with the results.
I think this project taught me a lot about robotics and the importance of software, and also the importance of the collaboration between software and hardware. I never realized that the two went so well together. And I had never worked with software before this project, only where I think it taught me a lot. It's a little bit scary and difficult at first. I learned from this project.
I also learned a lot from working with a group of people on a project. Most of the projects that I've done before with robotics, both hardware and software, have been basically alone, working with only supervisors and people to check up on you. But working with others definitely gives others perspectives.
Well, thank you all for watching our final project presentation. That's all.